Thank you, Ritu. I request you to please give me the permission so that I can present my screen. Thanks for an extended introduction. Good afternoon to all the participants.
Good afternoon, sir.
Good afternoon. The organizers, please allow me to share my screen.
Share this. तो सबको allowed no? Sir, you may push that button which is.
नहीं, वो नहीं हो रहा. Only meeting organizers and presenters can share.
Just a minute, sir, please.
Yes, sir. Pankaj, sir. Pankaj. I will just tell Pankaj.
Hello, sir. Good morning, sir. Myself, Dr. Viren Sharma from Jaipur. Jan sir, I am audible, sir.
Yes, Sharma ji, you are very much audible.
Yeah, okay, sir.
Good afternoon. Good afternoon.
Sir, good afternoon, sir. आपको देख के सर एकदम एनर्जेटिक हो जाता हूँ सर आपको देख के.
क्या बात है. Thank you very much.
थैंक यू सर, क्योंकि आईटी में डॉक्टर धीरज पलोलिया सर के साथ में मुलाकात हुई थी.
Okay.
बहुत पहले हुई थी 2010-11 में. तो लेकिन आपको जब भी देखता हूँ, लास्ट एफडीपी में भी देखा था, तो बड़ा आई एम वेरी हैप्पी टू सी सर.
It's my pleasure.
Yeah,
sir, now you may. Thank you, sir.
And I think now my screen is visible.
Yes, sir, it is visible, sir.
Okay. So I welcome all the participants in this meeting. Thanks to Dr. Bhupendra Singh and Professor Vinay Thapar for giving me this opportunity to share my views related with recent trends and uses of renewable energy. We consider hydrogen as future fuel, which is used for generation of power and can be utilized not only for feeding to the grid, but at the same time we can see a significant role or the alternate of fossil fuel in transportation systems. So keeping that in mind, let me just take one more minute
Sir, mic is off, I think.
Just a minute. I think, am I audible?
Yes, sir, you are audible,
Yes,
sir.
sir.
Yeah. So let me just start the lecture with a brief introduction about Sant Longwal Institute of Engineering and Technology, where currently I am working. This institution was established by Government of India in 1991, and since last 30 years we are imparting technical education through our multi-entry, multi-exit options. We admit students after 10th with an objective to bring them in the main stream of technical education through skill development. The student may exit with a certificate after 2 years. If they wish, they may continue in the third year and can exit with standard 3 years diploma. At the same time, we allow entry in the first year of this diploma program for ITI students. Even 12th standard students may come in the second year of this diploma program. Then 50% of these students are admitted who are academically good, again through a selection process in the second year BE, whereas first year BE admissions are given through JEE mains. So that way, since last many years, we are imparting multi-entry, multi-exit technical education. And I hope that in NEP, this particular concept is being highlighted, and for which we are already working. You can see the lush green campus. Every Friday we observe no motor vehicle day in the campus, and you can see the picture of our board members. The board meeting was on Friday, and everybody ride bicycle just to avoid the use of uh, motor vehicles on this particular day. So that way we can say that yes, we encourage our student through lead by example. Our faculty staff follow certain idols, and then we ask our students to follow them. As far as coming to the topic where we are talking about use of hydrogen as a future fuel through fuel cells. So fuel cell is basically, it generates electricity by an electrochemical reaction in which oxygen and hydrogen rich fuel. Here hydrogen rich, of course, we are concerned with pure hydrogen with 99.999% purity. So when this hydrogen, pure hydrogen combined with the oxygen and heat is generated at the same time, water, distilled water is generated as a byproduct. Unlike internal combustion engine, the fuel is not combusted, rather the energy being released through electrocatalytically. In that way, a fuel cell has to be a highly energy efficient, especially if the heat produced by the reaction is also harnessed for space heating, hot water or refrigeration kind of application. Now, if we just compare a fuel cell and a battery, is the battery is also an electrochemical device, but it is a closed system which generates electrical energy from the conversion of its stored electrolyte. And once this electrolyte is fully exhausted or converted, the battery is depleted and need to be recharged or replaced. On the contrary, the fuel cell continuously provided with the fuel, which is the hydrogen and oxygen from the atmosphere, and it generates power indefinitely. But indefinite means here is for the rated lifetime. There is some life cycle of everything, and so is with the fuel cell. Now, if we talk about the history, the concept is not new. The concept of fuel cell was first introduced in 1801. Further, it took around 35, 36, 38 years. In 1939, then William Grove invents the gas battery with the first fuel cell. After the first 18th century, somewhere around 1950, General Electric invented the proton exchange membrane fuel cell, and that was used in transport system. So it took around 150 years to basically evolve the technology and bring it into the commercial use. After that, after 1950, a sudden increase was noticed in the fuel cell applications. Then you can see that somewhere around 20th century, 21st century, 2007-8, they were explored as a major fuel source for transportation applications. Whereas in 2009-10 onwards, they are started being used in for low power applications like chargers, etc. Now, currently, if we review the applications, so fuel cells are being used these days from a few watts or rather milliwatts applications, from toys to large power plants of the order of megawatts. From vehicles where your power consumption is few hundred kilowatts to mobile chargers, few watts. From household power, that is 1 to 3 kilowatts, to battlefield power, say for example radar application in the military applications. The fuel cells basically are classified into three broad areas. Portable power generation, because we are not talking about their application from few watts to megawatt. So we call them for the portable power generation. Then stationary power, portable power generation, where we have the movement. Stationary power generation, maybe say for example as an alternative of diesel generators, the object is not moving. And the third category is power for transportation, which we are going to cover in this particular lecture. So as you can see that portable power generation of through fuel cell ranging from say 5 watt application to 500 kilowatts. So you can see in transport application where 100 kilowatt fuel cell requirement is there. So we have these are the hydrogen tanks basically designed here in the rooftop of the bus. Then fuel cell is placed here, and from here we basically have an electric drive system. They will charge the batteries and then we'll drive the wheel either through batteries or directly from the fuel cell. You can see the application in military applications. Say for example, many gadgets are being used by the military officers. Say for example, night vision goggles, basically GPS unit, and they need to be powered. So you can see that these fuel cells can be carried in the backpack, and the soldiers can also keep some spare fuel cell cartridge in case if the battery or the fuel cell get its life exhausted for that particular duration. Now you can see that somewhere around 2012, the hydrogen fuel cell bus was launched in Austin, Texas. In fact, a concept of zero, that is zero emission resource organization, they drive the fuel cell craft from Oslo to Monte Carlo in January 2012. And the Hyundai was basically the car manufacturer. They named the vehicle iX35 fuel cell electric vehicle. So the main concern here is that it is reflected from these pictures that we are considering fuel cell in transport system as emission free transport system, because the fossil fuel, they are causing a lot of pollution. So while we talk about pollution, transport is one of the major sector, and that is why we are considering them for the transport application. Now, of course, like conventional fuel, petrol, in diesel engines are available. Refueling stations are available on the entire network, highways in cities. So while we talk about using the hydrogen as a fuel for transport system, we need to think about the refueling station. And you can see these refueling stations are very similar to our conventional refueling stations. Even you can see the hydrogen refueling station was built for Arctic driving center in the remote areas some around 9 years back. Coming to the stationary fuel cell, in fact, there are remote areas where transmission and distribution of power is economically not feasible. For such remote areas, stationary fuel cells might be very useful. So you can see that for household applications, we can put some fixed capacity of fuel cell uh, at the residences, and all electronic gadgets can be powered. So they can provide the electricity for sometimes as and when needed, or till the availability of fuel. But of course, we'll consider that in such stationary fuel cells, they are not designated to be moved because our object is stationary. So these basically include the combined heat and power, uninterruptible power supply. You may use it for the generation of heat as well. There are countries like US, Canada, where the temperature goes in the minus. Even in India, we are using heaters these days in winter seasons. So for heating application also, these fuel cells can be used, and they are available for stationary applications in the range available from 0.5 kilowatt to 10 kilowatts. Now the question is that how we can produce the hydrogen, how to generate the hydrogen. So this is available in abundant quantities in the universe. Very little of it is here on earth in freely available form. So that means though it is available, but not freely available. So of course, we need again first some energy to produce the hydrogen. So you may ask, we need the energy to produce the hydrogen and then we are using the hydrogen. So this is basically not meeting the principle of law of conservation of. I'll give you at a later stage. But one thing is for sure that we need to extract these from the compounds. So there are two ways basically. Either we can generate by electrolysis or by fuel reforming. By electrolysis, we can split the water into its component H2O. H2O can be splitted in hydrogen as well as oxygen through the process of electrolysis. And then basically it uses an electric current and water to produce the hydrogen and oxygen. So as I told you, you need the electrical power to basically split hydrogen from the H2O. The key issue here is the requirement of a source that maybe you need to obtain from grid electricity or from renewable energy such as wind and solar. So here is the answer. We have some other sources of energy like wind and solar, and that too are can be harnessed only when either wind is available or sunlight is available. So during daytime, when we have enough sunlight available, that time we do not use the electricity. Most of our electricity uses are during the evening and night hours. Daytime we need it for refrigerator, air conditioning, etc. But demand in little less. So what we can do is that the solar power available during daytime can be used to produce the hydrogen. This hydrogen can be stored and can be utilized as and when required. So based on this principle, most of the wind, so is with the wind. The wind power is available when there is sufficient wind velocity available. Whether at that time we have the need or load of power or not, doesn't matter. So these days, now we are thinking all the wind and solar power plant are installed with hydrogen production unit as well. Power available through wind and solar can be utilized for hydrogen production. Hydrogen can be stored, then it may be transported to the place of use and can be used as a fuel in fuel cells. So a number of companies, in fact, a lot of efforts are going on. Yeah. We are using the number of companies, they are working on this particular concept to produce the hydrogen with wind or solar power. The second possibility is by fuel reforming. So basically there are several type of hydrocarbon fuels such as natural gas, methanol, gasoline or ethanols are available. Recently, if you are aware, our transport minister Sri Nitin Gadkari ji has talked about use of ethanol as an alternative fuel for two-wheelers and three-wheeler application. So that will serve two different purposes. That ethanol basically is produced from the as a byproduct from the various that can be grown in the farms like from sugar cans. So that basically allows the farmers to produce sugar cane and the waste material can be utilized for the production of the ethanol. And the cost will be somewhere around 60-65 rupees, which is much lower than the cost of the petrol diesel, which ultimately we are importing. We are not self-reliant. So that way, in fact, either we can use this ethanol for production of hydrogen, which can be used for the production of the electricity through fuel cell. Then they are not necessarily fossil fuels. Reforming of bioethanols, for instance, is equally possible. So now coming to the advantages. You can see the heat engine generators. The chemical energy is utilized to generate the heat. This heat through mechanical motion will generate the electricity. Whereas in fuel cell, the chemical energy is directly converted to the electricity. So of course, less or no number of conversion stages are less, and hence the efficiency is higher as compared to our conventional heat engine generators. Now, as far as the advantages are concerned, so we can see the advantages of fuel cells, the use of hydrogen as a future fuel, which is considered to be a clean and green renewable power, portability and suitability for electricity, either electricity generation or heat generation. So both the ways are possible. They can be used for emergency loads. Then, of course, these days the megawatt of generation through fuel cell is possible, and we can talk about grid interface for distributed generation. And meeting this particular demand during peak load, like we are using the hydropower plants for meeting the peak load demands, because they are easily placed into the load or removed from the grid. Whereas the base power is provided through the conventional sources. Let me check my another connection. Upendra, I am audible?
Yes, sir, you are audible, sir.
Okay.
Sound is audible. A little bit. एक बीच में disturbance था थोड़ा सा.
Okay. मेरा एक let me just go on the standby connection as well.
Sir, no issues, sir. Please, sir.
Okay. So now this particular slide is showing you a comparison of distributed power generation technology. We are comparing diesel engines, turbine generators, photovoltaics, wind turbine, and fuel cell. This data is 3-4 years old, so you might find some difference in recently available figure, but this will give you a clear-cut indication that the capacity range, in fact, the photovoltaics are now available in megawatts. So is with the wind turbines, and fuel cells are also available, rather even a smaller power generation, 100 watts to 3 megawatts range. The efficiency, you can see that among all these category, the efficiency of fuel cell is highest in the range of 40 to 57% as compared to, yes, solar is of course an option where the efficiency is low, but in fact recently also a lot of research is being made in solar PV panels where further efficiency can be increased. But of course, as compared to diesel engines, which not only cause pollution as well as it's a noisy operation. So that way is also generation through fuel cell can be preferred. As far as the capital cost is concerned, yes, it is little bit expensive, but in fact, one particular component known as membran used in fuel cell is now being started manufacturing by several companies, and this cost will definitely come down. However, we can see this operation and maintenance cost is also very low as compared to other sources. Now you can see this is basically the principle of power generation through fuel cell. Okay. You can see that like I am not able to see any of you. If some of you can switch on your cameras.
Participants, please switch on your cameras.
So that at least I can see that I am interacting with someone.
Participants, I request all of you to switch on your cameras.
At least few of you can switch on. Yeah, now I can see a few of you, so that now I can see I am talking to someone rather than talking to screen. Okay, so you see this is very similar to a battery. We'll have an anode and cathode. There are some catalyst, and then we'll use this electrolyte, the membrane in between. So mainly it is the main costly affair is this membrane, and now many companies are coming forward for commercialization and its production. So cost of fuel cell is significantly reduced. So we allow the hydrogen from hydrogen tank to go through this particular assembly. Oxygen from air will come combined with the electrons is freed, which flows in the external path and generate the electricity. And then later on these hydrogen ions combine with the oxygen ions and form the H2O, which is a byproduct, and this is the distilled water is produced. So there are basically different types of fuel cells are available in the market based on the technology used. So basically there are 5 types: proton exchange membrane fuel cell, AFC, PAFC, MCFC and SOFC. So now you can see the main difference is type of electrolyte is being used. Different type of materials are being used as electrolyte and their operating temperature. So you can see that PEMFC, the operating temperature is in the range of 50 to 100 degree. Whereas for SOFC, it is you have to handle temperature up to 1000 degree. So that is why these PEMFC, they are used for domestic applications, whereas SOFC, MCFC type of fuel cells are being used for bulk power generation. As far as the fuel is concerned, of course, MCFC and SOFC we can use in addition to hydrogen, CO, CH4 and other hydrocarbons can also be used. And that is why they are being used in the large power generation. Of course, if you have to handle large amount of working temperature, we can get the efficiency even greater than 50%. Which is limited to 35 to 45% in PEMFC. Now, one or more important point is that we have seen one cell. This is one cell. So like your batteries, we have the cell assembly to create a 6 volt or 12 volt battery. And then we'll connect the batteries in cascading to increase the voltage to 24, 48 and so on. Likewise, here also, these cells are basically manufactured to generate a voltage 1 to 1.1 volt. Then we'll connect these cells in cascading to make a fuel cell unit rated for either 24 volt, 36 volt, 48 volt and so on. Then generally the commercial units are available either in low voltage for low voltage application or 24, 36 and 48 volt units, and then these units are connected in cascading to generate the high voltage. So you can see that recent development in fuel cell, this PEMFC is available from 0.1 kilowatt to 100. So basically we can say few watts to few hundred or few tens of kilowatts PEMFC. Whereas MCFC and SOFC, they are available. You can see MCFC, they are available in some around 50, 60 and 100 megawatt range as well. Now we have one big issue with the fuel cell is that its drooping characteristics. You can see this particular characteristic as we load the unit. This is x-axis. You can see the current density, which is milliampere per centimeter square. So as we load the cell, its voltage drop. So at no load, open circuit voltage is around 1 to 1.1 volts. As we load, this voltage drops significantly. That too, you can see this particular region as well as this particular region, this drooping characteristic is non-linear. So basically you need to model like a battery. In battery, this droop is very less. Once we load the conventional battery, the drop in voltage from no load to full load is just 1% or 2%. From 1 volt, it may come down to 0.9 to 0.95, something like that. And that too with after some time interval, the battery voltage drops. But here, this is a significant problem with the fuel cell, and it is very necessary to basically improve the voltage profile. And that is why so big amount of electronics is required to maintain this drooping characteristics. Like a battery, even the voltage drop is little bit complicated, and it's classified into concentration region, ohmic region, and activation region. So basically you can see the reason for concentration and polarization. In between, we'll have the ohmic polarization where characteristics is almost linear. So to maintain this voltage constant, we'll use some electronics and power electronics circuitries. So that is another area of research for maintaining the voltage constant. Now coming to the need of vehicle electrification, we want independency from gasoline. We wish to reduce the pipeline tailpipe emission. You must be aware of Bharat 2, 3, 4. Very recently, which version of vehicles are being launched? Bharat? BS6. And even you might have heard, in fact, that some car manufacturing companies, they are now planning to stop a typical type of IC engine based engines, because basically they are not able to meet the BS standard implemented by Ministry of Transport. So that is why a lot of changes are being coming up, that tailpipe emissions should be low. So I request the participants to go to the Ministry of Transport website. As well as the websites of vehicle manufacturers to know about what are the standards are being used to control it. There is some echo coming through. So I request the participants to please switch off your mic. Yeah. So we'll have a stringent regulation for tailpipe emission of ICE based vehicles. Please, I request the participants to mute your mic, please.
Sir, I have done it, sir.
Okay. Then fuel economy and improved performance. So this is the technical point. Independency from gasoline, economic issue. Tailpipe emission, against pollution related concern. But the economy of fuel and higher efficiency and improved performance of the vehicle. This is one of the reasons why we go for the electric vehicle. Then utilization of renewable and non-conventional energy sources as much as possible. In fact, we can use the non-conventional energy sources, and that is fuel cell is one of them, where if we can use the hydrogen as a fuel. Modernization of vehicle with increasing electric loads. Computerization of sophisticated electronic controllers. In fact, most of the circuitries in vehicles are electronic these days. Then this has become possible due to technological advancement in power electronic converters and electric propulsion system. In fact, you must have heard about the hub motors. In two-wheelers, the motor can be placed in the hub, in the wheel itself, and that is way we can basically increase the comfort or the performance of the vehicle. If the hub motors are not available, it is really difficult to develop the electric vehicle. So these are some of the reasons that why we are going for the electrification in transportation system. The participants, I request you can refer. We have contributed a chapter in Power Electronics Handbook 4th edition by M.H. Rashid. So one complete chapter on fundamentals of power electronics controlled electric propulsion is devoted. So those who are interested in this particular area, they can refer this for the possible trends in the research in this particular area. Now, when we are talking about the electric vehicles, so they are basically classified into different categories. Electric vehicles, then we have another category, hybrid electric vehicle, PHEVs, plugged in hybrid electric vehicles, and FCVs, fuel cell vehicle. ये चार्जर लगाना पड़ेगा. So now you can see that these different type of vehicles are being basically developed, which are represented here with the help of size versus distance. So you can see on x-axis vehicle driving distance, and the y-axis you can see the vehicle size. Vehicles are basically, we use a few vehicles like two-wheeler, three-wheelers. They are basically used in cities for low distance operation, okay, for few kilometers, whereas we'll use the vehicles like our cars and we can use few hundred kilometers. Then passenger cars can accommodate 2, 3, 4 or 5 persons. When you need to accommodate large number of people, basically we'll go for the buses, etc. Then trucks, delivery trucks, which need to carry tons of the weight. Any of you, do you have any idea about the load of trucks in terms of weight? How much weight can be loaded in commercial trucks? Any idea? The trucks used for delivery, etc. Any idea, some of you?
It may vary from 5 ton to 20 ton.
Yeah, anyone else? No, because why I am asking you, I believe most of you attending this particular lecture or courses, they are either teachers or research scholar. Okay. So as a teacher, we need to face the queries from the students, and sometimes we need to encourage them to ask the questions. So in fact, for the cars, you might be aware about, it is basically have a registration for either 4 passengers, 5 or 7, isn't it? We know the SUVs. SUVs are basically have the registration from 5 to 7, including driver. Okay, small car, 4 passengers. Then we'll have another category 4 plus 1 up to 5. Similarly, for the delivery trucks, some weight limits is there, that is in few tons, from, as somebody answered it, 5 to 20 tons. So that much of weight we need to carry, and your basically driving propulsion system should be able to produce that much of force and torque. So you can see that for a small distance, a small size will have either delivery cars, electric cars, e-motorcycle, e-bicycle, and vintage, etc. They are basically battery electric vehicle, and they are purely using the batteries, which are can be recharged at a fine interval of time. Of course, only for short distance vehicle. Then we'll have the hybrid electric vehicles. The hybrid means the combination basically which are used widely used vehicles are mostly hybrid, where we have the possibility to use the conventional fuel, petrol, diesel, as well as basically batteries or fuel cell kind of thing. So you can use the gasoline, CNG or any other biofuel plus batteries, but their size is larger than the small cars and they can go up to some larger, longer distance. After that, you can see we'll have the third category, FCVs. The fuel cell vehicles, they use hydrogen plus battery oblique ultra capacitors, and the fuel cell HD trucks, fuel cell delivery truck, fuel cell buses, even fuel cell cabs, they are available in large size as well as you can run them for even long driving distances. So let's say when we are talking about a 2x2 bus running from Bhopal to Mumbai or Indore to Mumbai, rather than hybrid or battery operated, we have to go for the fuel cell based trucks or fuel cell buses, so which have that particular capacity to accommodate the passengers or weight and driving distance as well. Now, as far as the characteristics of different electrified vehicles are concerned, so you can see that this particular table is giving you information about the car models of different manufacturers. So we'll have a category battery electric vehicle, then we'll have a category hybrid electric vehicle. Then you can see the companies and their models. So Smart, Fortwo Electric, Ford Focus, Nissan, BMW, Kia. Now the Kia, this car is available on Indian roads. Similarly, the hybrid vehicles where we'll have the conventional gasoline based fuel tank as well as the batteries. So Toyota Pyrus is a very popular model. BMW, Honda Accord, Volkswagen, etc. Now you can see that with this particular table, range is an important parameter. That is distance run per charge. The big question is that how much a vehicle, in conventional vehicles, we can have the full tank around 30 to 40 liter, and then you can drive up to 300, 400 or 500 kilometers. After that, we need not to bother because we know that refueling stations are available at different distances. So when my tank will be empty, I will refuel it. But this is not true in case of electric vehicle. Once your battery will get discharged, how to charge, and then how much charging time is required. This is a big question. So that is why these manufacturers, they are talking about range of run per charge. You can see that the battery electric vehicles are 70, 80 miles to 120, 30 miles. Whereas hybrid electric vehicles, we can say few hundred miles, 640, 310, 420 miles, etc., etc. At the same time, you can see the top speed which we are able to achieve. So we are talking about two-wheelers and three-wheelers. We are running in cities. The top speed required is 30, 40, 50 kilometer per hour. Whereas cars, you can go up to 80, 90, 100. But even the buses which are used on highways, we can go even 120, 30, 40. Recently, there was a video made viral on WhatsApp and social media where our transport minister Gadkari ji has tested his highways. Are you aware of what speed they have achieved on those highways? Probably that was some Mumbai, that highway, if some of you can remember that.
170 kilometer per hour.
170.
Yes, sir.
Yeah, and if some of you can remember that highway on which the test was made, it was Delhi to Delhi Mumbai highway, somewhere MP में कहीं से आगे. So basically now, in fact, we are developing such type of roads where we may expect a speed of 170, 180 might be. So this is another parameter which need to be taken care by the vehicle manufacturer. Then charge time. So you can see that these, you can see 2.5 hours, 5.5 hours, 9.5 hours. Similarly, for these hybrid electric vehicle, 2 and 3 hours. So do you think that currently how much time it takes to refuel? It's hardly 5-10 minutes. So charging time in few hours was a constraint. So either we have to think for refueling station, maybe hydrogen can be used as a fuel for the fuel cell. So, and the power will be generated again through DC power generated by fuel cell, but the fuel will be hydrogen. So your vehicle will be EV, electric vehicle, operated on hydrogen instead of gasoline. And I have shown you the figure, the pictures where hydrogen filling stations are available. Now, as far as the hydrogen transportation is concerned, yes, that is a big challenge, but hydrogen can be very easily transported in solid form. You might have seen the industrial cylinders. आपने देखा 4-5 फीट का होता है. कोविड पीरियड में भी ऑक्सीजन सिलेंडर्स की बड़ी डिमांड आई थी एंड वी ऑल आर नाउ अवेयर अबाउट दीज सिलेंडर्स. सो यू कैन सी 4-5 फीट हाइट है, 1 फीट करीब डाया होता है, एंड दैट can hold, these industrial cylinders can hold up to 7, 5, 6, 7 cubic meter of the gas. तो जितनी हाइड्रोजन आप इस पे 5 फीट के सिलेंडर में स्टोर कर सकते हैं, गैस इन गैसेस फॉर्म, दिस हाइड्रोजन कैन बी स्टोर्ड इन सॉलिड फॉर्म इन अ 1/2 लीटर बॉटल. तो अब आपको क्या करना है, वन ऑफ माय टास्क इज प्रोडक्शन ऑफ हाइड्रोजन, okay, which is available in abundant quantity but not in free form. Okay, they are available in some compound form. तो वहां से आपको पहले तो हाइड्रोजन एक्सट्रैक्ट करना है, फिर फॉर ट्रांसपोर्टेशन आपको गैसेस फॉर्म से सॉलिड फॉर्म में कन्वर्ट करना है. सो ऑल दीज आई सी एज एन अपॉर्चुनिटी. ऑक्सीजन सॉरी हाइड्रोजन कैसे एक्सट्रैक्ट करेंगे, फिर उसको ट्रांसपोर्ट करने के लिए, तो मैंने बताया लॉट ऑफ रिसर्च इज गोइंग ऑन इन दिस पर्टिकुलर डायरेक्शन. और 7 क्यूबिक मीटर हाइड्रोजन वो एक बड़े सिलेंडर में स्टोर होती है. यदि उसको हम सॉलिडिफाई करें तो वो आधा लीटर वाटर बॉटल के शेप में स्टोर की जा सकती है. देन नाउ यू कैन थिंक यस, इट इज वेरी इजी टू ट्रांसपोर्ट दी हाइड्रोजन. और वो आप ये कर लेंगे तो जैसे दीज डेज वी आर मूविंग फ्यूल टैंकर्स, ठीक है ना, आपका ट्रेन से पेट्रोल डीजल डिपो तक पहुंचता है, वहां से फिर यूजिंग दी फ्यूल टैंकर्स आपको रिमोट एरियाज में टैंकर से पेट्रोल पंप तक पेट्रोल डीजल पहुंचता है. सिमिलर वे वी कैन ट्रांसपोर्ट इट फ्रॉम वन प्लेस टू अनदर प्लेस. Then one more parameter is battery kilowatt hour. आप जो बैटरी इंस्टॉल कर रहे हैं, because the battery is one of the heaviest and bulkiest component on your vehicle. So how much you can store, because it carries weight. So that basically ultimately, और उसके बाद आपके vehicle में the main purpose is not to house the battery. आपको मेनली वहां पैसेंजर्स को बिठाना है, द मटेरियल जो लोड करना है आइटम वो रखना है. सो यू हैव सम कंस्ट्रेंट ऑफ बैटरी वेट एंड हेंस द लिमिटेशन ऑफ द बैटरी कैपेसिटी, कि आप कितना बैटरी रख सकते हैं ऑन बोर्ड. देन हाउ मच रेटेड पावर आउटपुट इज रिक्वायर्ड टू प्रोवाइड द नेसेसरी फोर्स एंड ड्राइविंग टॉर्क. Then another issue is acceleration of the vehicle. आप लोगों ने देखा होगा, some of us एक बाइक कुछ दिनों पहले चलती थी, यामाहा के बारे में सुना होगा आपने, ठीक है, लगभग 10 साल पुरानी बात है, जब हीरो होंडा ने 4 स्ट्रोक इंजन लॉन्च किए थे and the objective was fuel efficiency. Can some of you give the fuel efficiency of Yamaha and Hero Honda? बाइक की जो बात कर रहे हैं हम, 70-80 किलोमीटर पर लीटर, but at the cost of compromise on acceleration. तो maybe the age of भूपेंद्र और इस जनरेशन के लोग हैं, उन्होंने perhaps they have not preferred the Honda motorcycle just for the fuel efficiency. जो यूथ था उनके पसंद यामाहा होती थी बिकॉज ऑफ हाई एक्सीलरेशन. और आपने कई लोगों को देखा भी होगा ऑन हाईवेज स्टंट करते हुए, दे बेसिकली सडनली गिव द हाई एक्सेलरेशन टू योर व्हीकल. बट हियर व्हाट आई एम टॉकिंग अबाउट, दिस इज द नीड एट सम प्लेसेस. आपको यू नीड फास्ट एक्सीलरेशन सो दैट यू कैन रीच फ्रॉम 0 to its rated speed. So based on these parameters, again we have certain constraint, and that is why these the vehicle manufacturers and different models are talking about, say for example, the first case smart Fortwo electric, it is 11.4 seconds. So that means from 0 to 60 miles per hour 11 seconds, it is basically very slow acceleration. So there are vehicles, say let's see BMW, it is 7 seconds. So this is one of the important parameters which needs to be taken care while we design the EV systems. Now classification, if we talk about on the vehicles broadly, conventional vehicle, they are called IC engine based, electric vehicle, then hybrid. In hybrid, that is combination of gasoline or hydrocarbon or gas fuel based plus battery. So you can see that there are different possibilities again. Either we'll have the series parallel HEVs, series parallel HEVs, and complex HEVs. Then we'll have another category, plugged in hybrid electric vehicle, and then fuel cell vehicle. And the basically distance versus size curve I have already shown you. Now coming to a conventional IC engine based vehicle. So you can see we'll have a fuel tank, an IC engine is there, we'll have a mechanical transmission system that will drive the wheel. So here you can say that the dashed line is indicating the hydraulic link. This arrow is indicating the power flow direction, whereas the thick line is indicating the mechanical link. So you can see we have the mechanical link in the wheels. So the faculty and research scholars are attending this particular lecture, presenting your idea concept in pictorial form. We will say that a picture speaks 1,000 words, probably if it is made and labeled properly. So basically I have especially pointing this particular point, that what things you need to reflect and in a way in any figure. So I hope moment I have displayed this picture, all of you must be in a mindset that yes, मैं एक vehicle को देख रहा हूं. Do you agree with me? ये पिक्चर में जैसे ही हमने व्हील्स और शाफ्ट से कनेक्ट कर दिया, आपका माइंड सेट बन गया, यस वी फील कनेक्टेड विद द व्हीकल. एग्रीड और नॉट?
Yes, sir. Agreed.
So that is one of my concern to all of you. हम क्या करते हैं, इट्स अ वेरी कॉमन मिस्टेक. बहुत लोग, मैं प्रेजेंटेशन देखता रहता हूं, योर प्रेजेंटेशन इज फुल ऑफ टेक्स्ट. पूरा पैराग्राफ आपने टेक्स्ट टाइप कर दिया और उसको रीड करना शुरू कर दिया, एंड द स्टूडेंट्स गेट, एक तो वैसे ही these days they are facilitated to the great extent. अभी उनके हाथ में माउस है, कैमरा और माइक म्यूट करने का ऑप्शन है, और जैसे ही आपने फुल टेक्स्ट फ्लो स्लाइड पर डाल दिया, we have basically detached them from the learning, isn't it? So how to make the subject interesting? Probably this is one of the possible way. Hope this is other than technical content which we are discussing. here. This is just how to prepare your slides, your presentations to attract the students. क्योंकि basically you put yourself few years back जब class में होते थे, we also notice these difficulty. जब हम student थे, पढ़ाई के अलावा बाकी सब करना चाहते हैं. As a teacher, we are expected to teach them the subject, complete भी करना है, and then we expect them to perform good in the exam. क्योंकि यदि अच्छा परफॉर्म नहीं किया, रिजल्ट ठीक नहीं आया, देन आई विल बी ब्लेम्ड. अच्छे टीचर नहीं हूं मैंने पढ़ाया नहीं है क्लास में. सो द की ऑफ सक्सेस lies here. Hope you all agree with me and will follow this practice. Now there is a comparison between IC and electric vehicle. So fuel tank is now replaced with battery pack, isn't it? You're basically IC engine and mechanical transmission is still there partly, but IC engine is replaced with power electronic converter and motor. Because battery is a DC power, your motor may be AC, brushless DC, whatever it may be, of a different voltage, whereas a battery voltage is something different. So we need power converters. So now you can see in this particular picture, again we'll have the thick line mechanical link, we'll have the narrow thick line, it is electrical link, and power flow. Power flow is basically missing here. Arrow लगाना मैं भूल गया हूं. So maybe here why? Okay, I not missed it, deliberately left it, because there is a possibility that power may flow from battery to motor or from motor to battery as well once it comes to electric vehicle. Then coming to a hybrid electric vehicle. Now in hybrid electric vehicle, that means now we'll have two energy sources. One may be your battery or fuel cell and another one may be your conventional fuel tank. अब हमने hybrid में क्या किया है? Gasoline based plus battery. So that means electrically or schematically we talk about there are two sources or more than two sources. So each source will have a power converter, and then power may flow from source to load and load to source, etc. So you can see this is my unidirectional power system where source A is transferring power to the load. This may be your conventional fuel source, whereas this may be battery, and the power may either flow from battery to load, or in case of regenerative braking, power may flow from load to source B, or we may charge this battery through your conventional fuel as well. So that is why this is a bidirectional power system and this one is unidirectional power system. So you can see this is the mode 1 where energy A and B both are supplying to the load simultaneously. This is mode 2, source A supplies power to the load. Here the shaded colored portion is transferring the power, whereas we are not utilizing any power from source B. Then we'll have the mode 3. We are not taking any power from the source 1, rather only source B is supplying power to the load. Now here you can see the power is supplied from source A to load, or at the same time source A is charging the battery. So power flow is among the source A and B. This is another possibility. Now instead of taking the power from the source, we can take the power from load, and maybe there are cases where we can have the regenerative kind of braking. मेरा ख्याल है आप सभी ने ये एक्सपीरियंस किया होगा while going to down gradient. जब आपने मोटरसाइकिल स्लोप में चलाई होती है, so what do? We close the engine. इंजन हम बंद कर देते हैं and we allow the vehicle to go by inertia. आप लोगों में से किसी ने ये फन किया है या नहीं किया है? To save the fuel. किया है या नहीं?
Many times, sir.
But don't do it with मॉडर्न व्हीकल्स, बिकॉज उसमें जो आपका कार्स हैं जहाँ इलेक्ट्रॉनिक्स हैं, आपके डिफरेंट क्या ब्रेकिंग सिस्टम होती है, वो काम करना बंद कर देता है यदि आप इंजन को बंद कर देते हैं तो। बट लेकिन आपने ये जरूर किया होगा, जब आप उसको फ्री रनिंग मोड में डाल देते हैं, द व्हीकल विल गो विद द ग्रेविटी एंड योर स्पीड विल इंक्रीज, तो आपका कंट्रोल ब्रेक पर आ जाता है, isn't it? We will lose the control on gear and entire control will come on brake, which is really dangerous. But of course, that is the way where we can have the regenerative capability, because our basically speed of the prime mover is the higher and battery voltage is low, so we can feed the power from load to source during that particular. Then we'll have another mode where energy from source A supplies power to the load and source B simultaneously. What we are doing, we are feeding the power to the load through source A, and at the same time we are charging the batteries as well. And one more option is there, when energy source B receives from energy source A and load, both the sources are now charging the battery. So what is the purpose of indicating you the possible modes of operation of electric vehicle, where we'll have the more than one source? We need to control the flow of power from one source to load, from source to another source, from load to source A or source B, etc. So lot of control options are required, and having a good controller is one of the requirement or need of hybrid electric vehicle. Now coming to, अभी तक जो आप देख रहे थे वो पिक्टोरियल व्यू ब्लॉक डायग्राम फॉर्म में था. Now let's see, come to the classification of this hybrid electric vehicle, where we are talking about series, parallel and complex. So what is my series HEV? Series HEV, again hybrid is conventional internal combustion engine plus battery. So you can see that I am having a fuel tank, I am having an internal combustion engine, the batteries are there. Then this IC engine is basically is operating a generator, and then through these power converters we are driving a propulsion motor which is providing the driving force to the wheels. So all these two sources, whether it is IC engine and battery powered motor, they are connected in series. That is why it is called a series hybrid electric vehicle. So either you can feed from IC engine directly only, you can feed only by batteries, we can feed both the source through both the sources, we can feed through IC engine, as well as your batteries can be charged from IC engine. Then we'll have the parallel hybrid electric vehicle. In parallel electric vehicle, what we are doing, that these two sources are connected in parallel. So either we can only feed through batteries, we can only feed through IC engine, or we can feed both of them in parallel. So this type of combination or architecture is called parallel hybrid electric vehicle. Then we'll have the series parallel combination. So now what we are doing in series parallel, your batteries and IC engine, they are connected in parallel. At the same time, a series combination is also made of IC engine through this generator and controller to motor or to batteries. In that case, my mechanical power has to handle a differential power of these two. That will put a different kind of challenges on my mechanical component. Then we'll have a complex HEV. In complex HEV is basically so far we have placed the batteries here and a fuel tank. Now here you can see that a fuel tank, IC engine, and then we'll have the electric storage through power electronic converter. We'll have the two different motors. You must have heard about four-wheel drive systems, isn't it? Four-wheel drives where your driving propulsion force is to be provided to both front wheel and rear wheel. Four-wheel drive, just to give the more power. So can some of you tell me the car we are driving in cities we are owning, it's a two-wheel drive or four-wheel drive? The car generally we are using is two-wheel drive.
Two-wheel drive.
Four-wheel drives are generally used for on where large amount of power is required in hilly areas or where roads are not there. So basically providing the propulsion force to both front wheel, rear wheel through IC engine and electric battery system through converters and electric motors will rear pose a big complexity on the system. Now we'll have one more category in plug-in hybrid. So for plug-in, basically we charge the battery. So far we did not talk about how the battery is going to be charged. Moment the PHEV comes, that means this battery is fixed and we use the grid power to charge the batteries. And then through that we'll have some energy storage system, power converters, motors, and of course your conventional fuel tank through IC engine will provide the propulsion force. Now coming to the fuel cell battery vehicles. So now you can see a fuel cell basically is again a category of hybrid. We'll have the battery pack, we'll have the fuel cell, and this hydrogen cylinder is used as a fuel or fuel tank. So now basically as compared to this, if we'll talk about this plug-in hybrid vehicle, as compared to that, this is an easy and better option that we still have a fuel tank, but instead of conventional, there is a hydrogen cylinder. Probably we have a mechanism to refill this fuel, and that in fact I had talked about earlier that yes, research is going on. People are thinking how to generate, how to store, how to transport the hydrogen, as well as how hydrogen refueling station can be built. So we are projecting this fuel cell electric vehicles as future generation of fuel. For electrical electronics engineer, another challenge is vehicle to grid and grid to vehicle. So now your car with a fuel cell is basically a power plant. It can generate the power. So in fact, if you are staying in a remote area or a place where no electricity is available, you can use your car to produce the electricity and feed the house. But at the same time, in a complex system, basically your vehicle can draw either power from the grid or it can supply the power to the grid as well in a microgrid system. So now here we'll talk about a comparison of vehicle, electric versus gasoline fuels. So basically the green and red colors are basically indicating that gasoline based system, transportation system will have certain advantages. Electric cars are offering basically a pollution free and advantage zone, and that is why they are reflected with green color. So no tailpipe emission, whereas greenhouse gases or pollution is generated. The utility companies basically they are promoting yes through use, whereas gasoline, of course, there is an industry, they refine petrol, extraction of petrol and all these concerns are there, which basically leads to some pollution, etc. Then range, 100 plus minus mile range. so far. But whereas gasoline based 300 plus range is available. So you can see here, yes, there is a need of improvement, but of course 100 miles per hour is it's almost a good speed. Time to recharge, it is in hours, whereas it is in minutes with the gasoline fuel. But as far as the operating or running cost is concerned, we can see that yes, this is the big advantage with EV. So now you can see that in a pictorial form, a conventional hybrid electric vehicle will have a gas tank which you can refuel, will have a plug-in point available to charge the batteries. Then we'll have the electric motor, so your battery can feed the power to the drive, or we'll have an IC engine like in the bonnet of the car we have a conventionally, and which can run through the uh, gas or gasoline based any other fuel, petrol or diesel, etc. This is the another picture indicating now here the table which I showed you earlier in block diagram form. This will give you a real picture with visualization, vehicle size versus driving distance. So you can see small vehicles, cars, then plugged in hybrid vehicles. So here our conventional passenger cars. Then you fuel cell vehicles, you can see HD trucks, delivery trucks, FCV bus. Of course, they can go for a longer distance without causing any pollution, and of the large size vehicles as well. There are some the components of electrical propulsion systems: energy source and storage system, power electronic converters, electric motors, and ECU. As I told you, when we control the power flow from one source to another, electronic control unit has to play a very important role. Now here is basically a representation of different categories. When we comes to electronic controller, you can see this controller will have the bi-directional signal flow from energy storage system, from power electronic converters, and from electric motors. These are the components. Then we'll have the driving force to the wheels. So as far as the electronic controllers are concerned, we'll have both hardware and software based tool like microprocessor, microcontroller, DSP, FPGA, DSpace controller. Then type of control methods, whether voltage, V by F control, field oriented control, direct power control, MARC based controller. Then we'll use some intelligent technique, AI techniques like genetic algorithm, artificial neural network, fuzzy based controllers. So these all are the part of the electronic controllers. As far as energy storage systems are concerned, either we'll use the battery technology as well as the ultra capacitors. For batteries, we'll have the NIMH, lithium ion, nickel cadmium, lead acid batteries, different type of batteries with certain advantage, disadvantage. Fuel cells, generally for transport application, we are using PEMFC. And then flywheel is there for energy storage. As far as power electronic converters are concerned, both AC to DC and DC to AC type converters, DC to DC converters are required, maybe with conventional as well as pulse width modulation techniques. The devices used, depending upon my requirement, from diode to IGBT, MOSFET, etc. are required. As far as electric motors are concerned, we'll have the various options starting from conventional induction motor, PMSM motor, SRM, and your DC motors as well. Then for analysis purpose, we'll use some CAD/CAM software, FEM, finite element method based softwares for graphical, thermal, and force management requirement. So this slide is giving you just an idea about the kind of technology involved in EV. That too is fuel cell based EV. And then some of you, based on your interest, may choose to either teach the subject of interest or can take the topic for your future research as well. With this, let me conclude here that we'll have some alternative of energy sources, we'll have some efficiency. Then there are factors which affects the design of ESS is energy density, power density, life cycle, size, safety, maintenance, and recyclability of the components. So with this, let me finish my delivery here. I understand because we are meeting in online mode, there might be thousands of questions in your mind. I'll try to answer a few of them. Thank you.
Thank you, sir. Now, participants, do you have any questions? You can ask questions to Professor Shailen, sir.
Sir, compared to electrically charged like nickel ion battery charged vehicles, how this hydrogen vehicles are cost comparative?
See, basically it depends. If you have only hydrogen as a fuel, or whether you are using a hybrid electric vehicle, even as on date, EVs are little bit expensive. And that is why, if you might have heard, recently Government of India has announced some basically benefits to the consumer who are going to buy the EVs up to rupees 1.5 lakhs. 1.5 लाख रुपए का जब आप फायदा दे रहे हैं, definitely cost of vehicle is above 10 lakhs or more than that. Fuel cell based vehicle, yes, as to my knowledge, is not being launched by any company, at least in India. But of course, the cost will depend on the mass production. It will not be much if we are able to have the recycling, refueling stations, and the manufacturers will come forward to manufacture these type of vehicles. That will depend. But of course, it's a vehicle which requires some kind of energy storage system, some driving propulsion system, and then fuel storage tank, which my current conventional vehicle still have. आपके पास एक fuel tank होता है, आपके पास IC engine है, and then mechanical arrangement to drive, and then we'll have the sitting space. Everything will be there. It is only whether, let me show you, yeah, this picture.
Yes, sir.
Can you see this slide, comparison of vehicle?
Yes, sir. Yes, sir.
Okay, so here you can see that I'm having
Because, sir, again, for the generation of hydrogen, we need some energy, and then that hydrogen has to be stored in a tank. And
yes, so you can see here, I'm having conventional IC engine, then this gas tank is there, then battery and charging arrangement. So if I am basically removing this IC engine, then this fuel tank can be used as a fuel. Or if this is a hydrogen, I can use this unit as a fuel cell unit, and this power generated can be used through the driving. You are absolutely right. We need power to generate the hydrogen, but solar power plant, when they generate, we do not have the use. What to do with power at that time?
yes.
When wind power is generating, we
Yes,
do
sir.
not have the need. Maybe peak time of the day or at the midnight. So basically, that is why I told you all solar and wind powers are coming with a hydrogen production unit. So when power is there, we have to store and then we can use at a later stage.
So it will become a storage means for hydrogen, for a renewable like solar or wind. That energy can be stored in the form of a hydrogen. Then it
Yes.
can be.
Yes. And this hydrogen can be produced, which is available in ambient, but not in free form. So we have to extract it. So what we can do when power from solar is available, we can do the electrolysis of water, produce the hydrogen and store it. And you can use it whenever needed. What currently we are doing, we are operating the hydropower plant for peak load. What you need, good water head to run the hydrogen power. If water head is not available, किसी साल में यदि बारिश नहीं हुई है, जो डैम आपने बनाया वहां sufficient water head नहीं है, you are not able to operate that particular plant.
Yes,
Isn't it? Now we'll have one more option. यदि मैंने हाइड्रोजन स्टोर करके रख लिया है, and I told you solidification of hydrogen is another research area. कैसे करेंगे? How we can reduce the size? How we can transport it? So in fact, the your diesel power generation, they are totally replaced by fuel cell based inverter, because diesel engines have the noise, isn't it? Perhaps in our institute we are having two 500 kilowatt DG sets operated on diesel. Almost every institution, almost every commercial organization, they need backup.
Yes, sir. Backup for
Okay. So in fact, we can see these the DG sats for emergency loads as a replacement by the fuel cell based inverters. Those will provide the silent operation. In countries like Canada, US, where heating of house is a necessity, people used to store 4-5 kilowatt fuel cell system with sufficient storage of the hydrogen, so that they can survive for a few hours in case there is no electricity from other sources. So for such application, when it is the concern of your life, cost is not an issue.
it
I
may
hope.
be one energy storage technologies.
Yeah.
Sir. Thank you, sir. Thank you very much.
Thank you, Bhupendra. If there is no more question.
Yes, I hope. Any other questions from participants?
I know there might be hundreds of questions in the participants' mind, and that is why we need to have such kind of discussion in person as well. Hope very soon we will overcome this pandemic and will be able to interact.
So we presume that there are no questions, so I can formally conclude the session. I express my sincere gratitude and thanks to Professor Shailen sir. He was my teacher and my PhD supervisor also. My personal thanks, sir, for a very wonderful, informative session, starting right from hydrogen fuel cells and going up to the technologies and developments in the area of electric vehicles. I would like to share with the participants that there is a book published by Rashid, the Handbook of Power Electronics. It is a very renowned book. Many of you have heard. A Handbook of Power Electronics by M.H. Rashid. And one chapter of Sir has been included this year. I hope so this year.
In 2020.
Yes, in 2020, one chapter of Sir has been included in Handbook of Power Electronics by Rashid on electric vehicles. So you can refer that also. So thank you very much, sir, for your informative session. We hope to see you soon and hear you more, sir.
Thank you, sir.
Thank you very much. Best wishes to all the participants. Hope the course will basically add something new in you as a teacher, as a research scholar. Thank you very much.
Thank you, sir.
Thank you, sir. Narayan, can you address something regarding feedback and attendance?
Yes, sir. I have circulated the attendance link and feedback link. Thank you, Salen, sir.
Okay, thank you, Dr. Patidar. Thank you. My best wishes to all the both the coordinators and entire team. Good luck.
Thank you, sir.
Very much, sir.
Narayan, you can brief them about the process of our attendance and feedback and chat and anything like ये अपन lunch से पहले बता सके.
जी sir.
Narayan, can you hear?
Yes, sir.
आप पार्टिसिपेंट्स को बता सकते हैं कि हम लोग फीडबैक और अटेंडेंस कैसे लेने वाले हैं और वो सब चीजें कुछ लोग पूछ रहे थे कि की नोट का फीडबैक फॉर्म कहाँ है, इस सेशन का फीडबैक फॉर्म क्या है, तो मेरे ख्याल से कॉमन फीडबैक फॉर्म हमने बनाया है, उसको मल्टीपल भर सकते हैं ना.
So, dear participants, we have just provided the feedback and attendance link in the chat box of this session. You have to fill this. This link is remain active for the next 10 minutes. So please fill it. And prior to this, you have to sign in with your account. Then only you will be able to fill this link. So please sign in with your valid email ID. Thank you very much.
Sir,
can I send this Google form? Can I send this Google form through mail also, Narayan? No, I can send the mail ID which they have registered on AICT portal.
Yes, sir. We can. We can.
I am having the mail ID of the participants which I have downloaded from the AICT portal. So we will send this form to their mail also. It will act as a feedback form as well as attendance, isn't it? It will serve as dual purpose.
Hey, Dr. Narayan Gupta ji, yes, actually this feedback link is not working currently.
आवाज थोड़ी धीमी है, आप कौन बोल रहे हैं? Who's speaking?
I think Dr. Virendra is asking that this is not working, the linking. Sir, link is working and so many have already filled. Please try again.
I have also seen.
Actually, already click on.
We'll be sharing it on your mail also.
Okay, thank you. I will see in mail.
So we will be meeting after in the post-lunch session, and you may be having the schedule of it. If you are not having, I will just let you know. We will be having our session at 2:30 p.m. Professor Sushma Gupta, Professor MNIT will take the session at 2:30 p.m. So please fill the feedback form and attendance form. In the meantime, we are also downloading the attendance from our Microsoft team platform on each session. Thank you very much. So we'll see you at 2:30 p.m. Thank you.
Please again share feedback link in chat box.
Sir, you are not audible at all. Please
Your
raise your volume. Please raise your volume.
Yeah, right. Okay.
Or just increase.
Okay.
Yeah.
I'm audible? Sir, audible?
Not at all, sir.
Oh, yeah. What is the problem? I think.
Write in WhatsApp group. If you are in WhatsApp group, write your query in our WhatsApp group.
Okay, sir. Okay, thank you.
Sir, we have not filled this feedback and attendance for the past session. So is it possible?
Just forget about the last session. Just fill it for now.
Okay. Thank you.
It is valid for both the session. It is valid for both the session.
Okay. Thank you, sir.
Okay, so we'll meet at 2:30 p.m. Thank you.
Thank you very much.